Question 4. We've got some dilute sulfuric acid, reacts with alkalis such as sodium hydroxide. Sodium hydroxide is known as caustic soda. It's used as a drain cleaner. The student believes a box of caustic soda has been accidentally contaminated. To prove this, the student dissolves 2 grams of the impure caustic soda in water, and the solution is made up to 250 centimeters cubed. 25 centimeters cubed of the solution of caustic soda is neutralized by 24.6 centimeters cubed of 0.1 molar sulfuric acid. Calculate the percentage by mass of sodium hydroxide in the impure caustic soda. Okay, so what you've got here, again, quite a long-winded question, lots of numbers floating around, and then an unfamiliar scenario. All right, just because you're calculating a percentage by mass doesn't mean you treat this any differently. It'll only be the last stage, the last step when you're actually doing this bit that will be different. The rest of it up until that point is the same as any other titration-based calculation you've ever carried out. Look at the information you've been given. Can you work out moles for something? Look at the equation for your ratio to work out the moles of your whatever it is you're looking to find out. And then from there, a bit of common sense will lead you to how to work these percentage by mass questions out. Do not let them phase you. So what have we got? I've got a volume and a concentration for my sulfuric acid, so I can work out my moles here. I can then use the ratio to work out the moles of sodium hydroxide present. Okay, and then I can use the moles to generate a mass, and the mass then is compared to the total mass used here to work out the percentage by mass. So let's start from the beginning here. I've got 24.6 centimeters cubed of 0.1 molar sulfuric acid. So let's start there. Moles of H2SO4 is C times V over 1,000, which is going to be 0.1 times by 24.6 divided by 1,000, which gives me a number of moles of 0.00246. The ratio in the equation is 1 to 2, so 1 mole of sulfuric acid will react with 2 moles of sodium hydroxide, so therefore my moles of NaOH is going to be twice this value, 0.00246 multiplied by 2 will give me an answer of 0.00492. Now this is where you have to stop and be very, very careful with this calculation and look back at the information you're given here. To prove this, the student dissolved 2 grams of impure caustic soda in water, and the solution is made up to 250 centimeters cubed. 25 centimeters cubed of the solution is neutralized. So what we have here, this value is for the moles of sodium hydroxide in only 25 centimeters cubed. Now remember, the number of moles is just a fancy way of referring to the number of particles. There therefore cannot be the same number of moles in the 25 centimeters cubed that was titrated as there is in the 250 centimeters cubed that you started with. This is a portion of that. This is 1/10 of the total volume that you used. So logically speaking, you've got 1/10 of the moles. So before you can go any further, you need to scale this number up. The number of moles you calculated here is for the number of moles of sodium hydroxide in 25 centimeters cubed. Therefore, in 250 centimeters cubed, you will have 10 times this number of moles, which is 0.0492. It's this little step that students sometimes miss. So you're looking for any instructions that involve taking a sample, taking a little bit out of a total solution. So this is the total number of moles that was in the original 250, and therefore the total number of moles that was in the 2 grams that was dissolved. So watch out for those little tricks. Let's carry on from there. So I've now got my moles of sodium hydroxide that was present in the original 250 centimeter cubed sample. So what I need to do is work out the mass. Okay, so if I come across here, remembering that mass is moles times by molar mass, or mass is Mr. Moles, as you might remember being taught. So number of moles, 0.0492, times by the MR of sodium hydroxide. Okay, the molar mass of sodium hydroxide, we've got 23 plus 16 plus 1. Okay, so 23, 33, 39, 40. So I multiply this by 40. That will give me 1.968 grams. So what this tells me then is that in the original 2 grams of caustic soda, 1.968 grams was actually sodium hydroxide. The impurity will not react. That's the whole basis of these questions. Your titration will not use any of the impurities. Only the bits that are actually going to take part in the reaction will take part in the reaction and therefore give you your answer. So this is my mass of sodium hydroxide. So to work out a percentage by mass, okay, it's essentially the same as percentage purity. So it's another way of referring to it. So percentage by mass will be the mass you just worked out, 1.968, divided by the original mass of your sample, your impure sample, which is 2. And then obviously for a percentage, I need to times it by 100. So if you do that sum there, your percentage purity will be 98.4%. Or your percentage by mass is 98.4%. It means the same thing.